Chapter 8 Chemical Equilibrium Second Hour Part 1 Equilibrium Constant Kc and Kp. At the end of the lesson, students should be able to define homogeneous and heterogeneous equilibria, deduce and write expressions for equilibrium constants in terms of concentration, Kc, and partial pressure, Kp, for homogeneous and heterogeneous systems. Equilibrium system can be divided into two different systems, homogeneous system and heterogeneous system. This is an example of homogeneous system. Both hydrochloric acid and water are in liquid phase. This is an example of heterogeneous system. Magnesium, which is a solid, is burned with oxygen in the air, which is a gas. In homogeneous equilibrium, reactants and products are in the same phase. What is a phase? Phase is a physically distinct portion of a system. For examples, you can see that all the chemical substances involved in the first chemical equation are in gaseous phase. The reactant, sulfur dioxide, and oxygen are in gaseous phase, and the product, sulfur trioxide, also in gaseous phase. So this is a homogeneous equilibrium. The same goes to second and third chemical equation. In the second chemical equation, the reactant and product are gaseous phase. In the third equation, the reactant and products are in aqueous phase. For a heterogeneous equilibrium, reactants and products are in different phase. For examples, in the first chemical equation, calcium carbonate solid produce calcium oxide solid and carbon dioxide gas. Both reactant and products are in different phase, so this is a heterogeneous equilibrium. For the second chemical equation, carbon dioxide gas react with carbon solid to produce carbon monoxide gas. So this is also heterogeneous equilibrium. Now let's see what is law of mass action or equilibrium law. For any equilibrium at a given temperature, the ratio of molar concentrations of the products to the molar concentrations of the reactants, both raised to a power equal to their respective stoichiometry coefficient, will be a constant. For a particular system and temperature, the same equilibrium state is attained no matter how the reaction is run. If you have a chemical equation like this, A mole of reactant A react with B mole of reactant B produce C mole of product C and D mole of product D. The equilibrium constant expression is molar concentration of C raised to the power of C multiplied by molar concentration of D raised to the power of D and divided by multiplication between molar concentration of A raised to the power of A and molar concentration of B raised to the power of B. The K is referred to equilibrium constant and the square bracket referred to concentration in the unit of mole per liter or M. The concentrations in the equilibrium constant expression are usually given in moles per liter, and so the symbol K is often written with a subscript C for concentration, as in Kc. Concentration of pure solids, pure liquids do not appear in equilibrium constant. Concentration of pure solid and pure liquid is the same at a given temperature, means it has the same number of mole per dm cube of the solid, just as it has the same density at any given temperature. When the reactants and products in the chemical equation are gaseous, we can formulate the equilibrium expression in terms of partial pressures instead of molar concentrations. For example, the Kp expression for this chemical equation is partial pressure of C raised to the power of C multiplied by partial pressure of D raised to the power of D and divided by multiplication between partial pressure of A raised to the power of A and partial pressure of B raised to the power of B. The PA stands for partial pressure of gas A and the unit is atm. The Kp stands for equilibrium constant for the reaction in terms of partial pressure. In quoting the value of Kp or Kc, the temperature has to be specified and the phase of each reactant or product must be included in the balance equation. For example, the Kc for this chemical equation is 1.67 at 500 Kelvin, whereas the Kp for this chemical equation is 4.07 to the power of -2 at 500 Kelvin. Please take note that equilibrium constant expression Kc and Kp are also called equilibrium law expression. Thank you for watching this video.